So today we are going to talk about the remainder and factor theorems. We're going to be using synthetic division to do this. We're going to start with a little warm-up of these three little questions that might seem like they don't really connect to each other, but I promise you they do. So when we look at number 1, it says, given this polynomial and the remainder when f of x is divided by x minus 9 is 1, then what is the value of k? Okay, so we know how to divide, right? We could divide with long division or synthetic division. Could I use synthetic division to divide that? Yes, because it's x minus 9. So if I can, I think that's what I want to choose. So yes, I have a if you notice there's a variable in that polynomial, but that's okay. We're going to treat it just like every other synthetic division one we had so far. So we're going to take all of these coefficients and we're going to put them in here. This is a 4th degree, so I should have 5, 1, 2, 3, 4, 5. So I have 5 things I'm going to write in here. I got a 7, negative 63, 5, k, because that's the coefficient there, and negative 80 for my constant. Put a little thing there for my remainder. Since it's being divided by x minus 9, that means a positive 9 goes out here. And then the other thing I know that I don't normally know is the remainder, and the remainder is 1. Okay, so I've put in everything I know, and now I'm going to go through synthetic division just like I know how to do it. So I'm going to drop the 7 down. 9 times 7 is 63. I combine these and they zero out. 9 times 0 is 0. Combine those and I get 5. 9 times 5 is 45. Then what do you think I would write here? 45k is the one version I heard. Y'all agree with that? 45 plus k. So I got 2 answers there, 45 plus k and 45k. Which one do you think it is? Plus k, okay. That's the most common answer for anything like that, and I get where your brain's going because you're putting them together, but then you got to make sure, because 45k means we're multiplying and we're actually adding these things. So it is 45. I'm going to put k plus 45 just because I'm old school and it was drilled into my brain that the variable comes first. Nothing wrong with 45 plus k, but it still pains me to write it. Okay, so since to get this 45, I have 9 times 5 gives me 45. I'm going to do 9 times this and put it here. So that's just 9 times k plus 45. I don't need to distribute or anything. I literally multiplied them. It's actually easier when there's variables because you don't have to do the work. You just got to make it happen. Then, since we added these to get this, I add these to get this. And I can set up my little equation. I can say that I know that 9 times k plus 45 minus 80 has to equal, I already had that, it equals 1. So now by running through the synthetic division, I have set up a little equation there, and I can easily solve for k. So I'm going to add 80 to both sides. I get 9 times k plus 45 equals 81. So then k plus 45 equals what? How do I get to there? Divide by 9. What's 81 divided by 9? 9. There you go. Thank you for talking to me. And then I subtract 45 from both sides, and what do I get? Anybody? Somebody talk to me. Negative 36. Okay. Not even asking hard questions here. So that is the value of k, right? So that's me using synthetic division to be able to find a missing coefficient in the polynomial, right? Which is something we should be able to do just because we understand synthetic division, okay? So like I said, the next two it's all going to seem very disconnected at first, but I'll bring it together. And one result of me redoing things at the last minute like I did is that there's clearly not two number ones, but not that that really matters. The good news is all the important stuff is right, but then my my numbers get all messed up sometimes. All right, so let's look at number 2 here. It says, consider the polynomial function, so it gives me 1. So the first thing it says is to divide the function by x plus 4. So that's simple because there's not even any variables in here. I can use synthetic division, so my negative 4 goes out here. Inside, this is cubic, so I have 1, 2, 3, 4 terms, so I'm good. So 1, 1, negative 4, and 41. This time, I don't know what my remainder is, but that's okay. So this is 1, negative 4, negative 3, 12, 8, negative 32. Okay, and then when I combine those two, what do I get? 9, right? Okay, so that means then my answer, because all it says was to divide, so this gives me x squared minus 3x plus 8 plus 9 over x plus 4. Okay. So we're going to let that sit there. We're going to do B. For B, I want to find f of negative 4. That means I'm just substituting in negative 4. So f of negative 4 equals negative 4 cubed plus negative 4 squared minus 4 times negative 4 plus 41. So no variables there either, so this should be pretty simple. I'm going to, I know that this is going to be negative. 4 times 4 is 16, times 4 is 64. Plus, this will be a positive 16 plus another positive 16 plus 41. So then when we get here, we work smarter, not harder, right? So 16 and 16 is 32. 32 and a negative 64, negative 32 plus 41. So f of negative 4 equals 9. So now look at our answers for A and B and think about why maybe we did both of these together. Do you see anything that maybe they have in common? The 9, right? When I found f of negative 4, I got 9. Look at our remainder here. It's 9. Okay? So what the remainder theorem says is we can actually use synthetic division to evaluate functions. So f of negative 4, I mean, those numbers weren't horrible, but what if it was f of negative 17, right? And then I had to cube negative 17, and then I had to square it, and I had to do all that stuff. Like, it's doable, I'm capable of it, but it's yucky, right? Whereas if I did negative 17 over here, then this would probably come out a whole lot better and it'd be a whole lot easier because I'm not cubing the big numbers and stuff like that, right? So it's another option to evaluate functions because just by evaluating f of negative 4, if I do synthetic division with negative 4, my remainder gives me that answer. Now, I'll be honest with you, I was even talking to Mr. Ackerman about this yesterday. Even though we know that, I never actually think to do it when I need to evaluate numbers. Like, that's not my go-to. I still just substitute them in and just go with it. But it's possible, okay? And that's one reason why we're talking about this, but we'll apply it to some other things, okay? So the remainder theorem then, off of that, says if a polynomial function is divided by x minus c, then the remainder is f of c. Okay. That's why when it divides evenly and you don't have a remainder, it's actually a factor. That's when your remainder is 0. So anytime you use synthetic division to evaluate the function, it's called synthetic substitution. Synthetic substitution. Okay. So let's do this example. So it says, given this polynomial, and I got a k in there again, and the remainder f of x, or the remainder when f of x is divided by x plus 3 is negative 20, then what is the value of k? So it's worded very much, probably almost exactly the same as the first thing that we did before we talked about the remainder theorem. So we're going to use the remainder theorem here, and let's think about what we know. since when I divide by x plus 3, this is my remainder. That x plus 3 tells me that what I'm using is x equals negative 3, right? So if that's the case, then I know that f of negative 3 is going to have to give me negative 20, right? That's what the remainder theorem says. When I substitute in negative 3, I'm going to get negative 20. So I can use that to help me find k. I can say then, all right, well, this is f of x. So I know from this, f of negative 3 equals, and then when I substitute it in, negative 3 to the 4th plus 8 times negative 3 to the 3rd plus 12 times negative 3 squared minus k times negative 3 minus 14. Not only does it equal f of negative 3, that equals negative 20 because I got that from here. So if you look at this, when I just underlined in orange, how many variables are in that equation? 1. It's the k, right? I have one variable. It's right here. So is it possible that I could solve for k with that equation? It's possible. Totally doable. It's not beautiful, but it's not really that bad, but I could do it. You know, I can do it without a calculator. I can multiply that stuff out and move it over and solve for k, and I can get my answer there. And that's one way to use the remainder theorem. But another way to use the remainder theorem is actually doing it this way, like we did before we ever talked about the remainder theorem, just by knowing what we know from synthetic substitution. Do you think that this way might be a little bit nicer and easier than what we just wrote down? I think so too. So I think that we're not gonna erase this or anything. I wanted you to actually write it down, so we'll just kind of put an X through it and say, you know what? I choose not to do it that way because I have choices. So instead, I'm gonna set up my synthetic division. I'm gonna divide by the negative 3. On the inside, this is a 4th, so I have 1, 2, 3, 4, 5 terms, so I'm good. I'm gonna put the 1, 8, 12, negative k, negative 14. And then I know the remainder, it's negative 20. So that's what makes it different than just the synthetic division that we've been doing. But now I just go through my synthetic division like I know how to do it. I'm going to bring down my 1. This gives me a negative 3. This is 5, negative 15, negative 3, 9. And then what do I put here? Negative k plus 9, good. Negative k plus 9, or 9 minus k is all k also, but then I'm going to multiply negative 3 times this, so that's literally just negative 3 times negative k plus 9. Then I have my little equation already set up. Negative 3 times negative k plus 9 minus 14, because when I'm going to combine these two, they have to equal that negative 20. That gets me my little equation for me to solve for k. Okay, so go ahead and solve for k. And what questions do we have? Anything? We're all good so far? If you can do synthetic division, you can do this. You just have to make sure you read and know where you need to put, if you can put stuff in the right places, it should be a piece of cake. Okay. All right, let's go to the next page. So now we're going to talk about, that was the remainder theorem. We're going to talk about the factor theorem as soon as my page turns. There we go. Okay, so it says, given a polynomial, my pen skipped, sorry. Polynomial f of x, x minus c, is a factor if and only if f of c equals 0. Okay, so given a polynomial f of x, x minus c is a factor if and only if f of c equals 0. Everybody okay with that? So when we read this example, it's going to sound very similar to the ones we did on the front, but it doesn't give us as much information. It says, given this polynomial, and I have a k in there, and x minus 7 is a factor of f of x, then what is the value of k? All right. Well, since we have that x minus 7, if I divide that into there, it doesn't tell me what the remainder is, but do I know what the remainder is? What would the remainder have to be? 0. Because if x minus 7 is a factor, then f of 7 equals 0. So my remainder is 0. So it does give me as much information. It just didn't flat out say it. Saying that it's a factor tells me what that remainder is. So now, knowing that, I'm going to do it the same way I did on the front. This is a cube, so 1, 2, 3, 4. So I'm going to put these 4 things in my synthetic division. Get 2, negative 7, negative 53, k. And 7 goes out here, and I know that my remainder is 0. So go ahead and run through that and see if you can solve for k without me talking you through it. Okay, what questions do you have on number 4? Anything? We good? The closer k is to the end, the easier this becomes. The farther k is over here, the more complex that would become. So it's nice when it's at the end. All right, then you do number 5, start to finish. Oh, and I forgot to say this last period, but up here, if you ever need a real mouse, on the left-hand side, there's clean mice, if you want to use them. And then when you're done, just put them over here, and then I'll sanitize them. All right, any questions? Did we get 2? We're all good with that? Any questions at all? Okay. And notice I'm not distributing this. If I did, it wouldn't be wrong, but there's no need to. So sometimes you end up making your life harder when you do that. So just kind of think about your end goal instead of just diving in and doing math. Okay. All right, so let's look at number 6. It says if this polynomial, no k in there, and if we have this and f of negative 5 equals 0, then we want to find all of the zeros of f of x algebraically. Okay, so one way to find the zeros of a function is to factor, but factoring by grouping is not going to work like that. I could use synthetic division like we did yesterday if I actually knew what one of the factors was. By what they told me, do I know a factor of this function? Yes. What is it? X plus 5, exactly. So if f of negative 5 equals 0, then this has to be a factor of it. So I do know one. So I can go ahead and divide and start breaking this up. So I'm going to put my negative 5 out here. This is a 4th degree. I have 1, 2, 3, 4 terms. I need 5 numbers in there. So fill out the numbers that go inside and make sure you don't forget your placeholder. We'll make sure we agree. Okay, everybody okay with all that? Right, got to have the 0 for that constant term that's not there. And since I know that this is a factor, I know what my remainder is. It's 0. So I'm not solving for k or anything here, but I do need to know what the next part of my function is. So we're just going to go through this, drop down my 3, get me a negative 15, negative 10, positive 50, positive 8, negative 40, 0, 0, and then you always want to make sure that those two actually do give you 0, okay? And they do. They won't always all 3 be zeros, but okay. So then what I know now that I have this f of x equals one of the factors is x plus 5. Then this has 4 terms, so it's a cubic. So this would be 3x cubed minus 10x squared plus 8x. Okay, so I know I've said a few times, because of the nature of how y'all are taking notes and working on things, I can't always see as much of your work as I would like. But what I did notice a few times yesterday, and it's probably a very big problem, I just can't really tell that, is that at this step, what I have written is what you have to have written. It is an equation that requires an equal sign, and it has this factor and all the rest. So when I multiply all this back, it actually gives me this, okay? Notation, what you're writing down, the way you keep up with your work, that's all things that are important always, but can get you to, if you don't do those things, you'll lose points on the AP exam. It's just the way that it works, because there's a certain way and a pattern and correctness to math. So you can't just have random stuff written down and try and get to the end, because if we want this factored all the way, then whatever I have better multiply all the way back to right there, and I can't be missing anything. Okay, so make sure that you're being careful. That's one of the reasons why I'm having you turn in some work, because I want to see some of those things. I'm not necessarily at this point going to go in there and like take points off for it, but I'll probably put some notes on there, just things that you need to focus on. Then the ball's in your court, and if you never do it, it's just going to hurt you. I mean, it doesn't hurt me. So I just want to make seur that you understand what you need to be doing. Okay, so with all that said, from here, go ahead and factor it the rest of the way and find your zeros. Okay, I want the fully factored form and to have the zeros written out at the end. And let me know if you're stuck or have questions along the way. Any questions? We'll say that like when you factor the x out here, I brought it to the front. If you don't bring it to the front, it's okay. But if it's in between, I would probably put it in parentheses so it doesn't look like a weird multiplication sign. Most of the time, excuse me, when you're factoring, if you have monomials, they come out to the front just so they don't get lost in the shuffle. As long as they didn't get lost in the shuffle, that's fine. But remember this, what we're supposed to have is the fully factored form. This is the fully factored form. If you don't have to write it, I don't write it either, okay, because we don't need to. Unless there's sometimes I'll tell you, I'm writing this down, but you could skip this step, or I'm writing this down just so I don't lose anybody. But pretty much everything I have, you would have to have written down to get credit. You might even have more if you did grouping for this, which most of you probably did. So you might even have another step, and that's okay too. But this is the bare minimum for sure, okay? What questions do we have? Anything? Alrighty, then go ahead and go to Google Classroom and click on the quiz for today. We're going to start this together. You're going to have 10 minutes, so the timers that count down, you know, if you stay under those timers that count down on every question, then you'll have plenty of time. If you let them run out, then might be short on time because I'm shutting it off. Well, after I hit start, I'm shutting it off after 10 minutes, so get there quickly. I'll try and wait for everybody, but if you're taking forever, I don't know.